How are you guys? Now let's talk about partial variation, the last type of variation. Remember, in direct variation, we're saying one variable increases, the other also increases. In indirect variation, when one variable increases, the other will decrease. In joint, we are combining both of these two mentioned, that is direct and indirect variation. But partial now, the word partial means partly, at times, sometimes. Yeah, that's partial. This variation exists between variables such that when one variable increases, the other may remain constant, that is, may not increase or not even respond, or at times it can respond. So you can easily tell that a given question will be partial variation through the terms partly and constant. For instance, you can say x, or let's talk in real life applications. The relationship between price and demand of basic commodities or essential commodities such as food. For instance, we say here in Zimbabwe, it's sadza, mini meal, cooking oil, fuel, and we talk more examples of essential products. Alright, suppose we have the price of mini meal in dollars and the demand of mini meal per month. If you are selling a 10 kg bag of mini meal at $5, our sales in a month, suppose it's 20 or maybe 50 bags. A 10 kg bag of mini meal is selling at $5, and in a month we are selling 50 bags. What happens if we increase price of mini meal from $5 maybe to $12? If you increase the price of mini meal to $12, just because mini meal in Zimbabwe's context is a basic or an essential commodity, demand might not change. Demand will remain 50 bags because we cannot replace this one. It has no substitute. That's our staple food. Demand will remain constant. Take note of this one. Demand will remain constant. Or at times, it will partly change. It will partly vary. Maybe, to our surprise, if you increase price of mini meal from $5 to 12, instead of the demand falling, the demand can even rise, but it will rise slightly or partly. The demand can rise up to 54 bags. In the month you increase the price of roller milk, then the demand increased, or it will respond slightly decreasing to maybe 47. So that's partial variation. There will be these two terms, constant and partly. The other variable remains constant, or it will partly vary or partly respond. That's partial variation. And how to approach that one? The word constant will be replaced by 1. And then we introduce addition. And this type of variation, unlike the other variations that we were talking about, this one will go with two constants, not just k, but k and h. Then you'll be also using simultaneous equations to find the value of h and the value of k, just like what we are going to do in this example. Example number 1. Given that x is partly constant and partly varies, as y. Number A, write down an equation connecting x, y, and two constants h and k. Number B, x is 4 when y is 8 and x is 3 when y is that was 4 and 8, and this one 5. Find the value of h and value of k. The last one, find x when y is equals to 10. Alright, this type of variation is called partial variation. You can easily identify it through these terms, partly and constant. That's partial variation. You will be replacing the word constant by 1. Then you will be introducing two constants, h and k, is what we are going to do here. Number A, given that x is partly, you write this symbol, constant, you write down 1. And partly, the other partly, that's addition, plus, then y. You ignore the word vary. You will not introduce another variation symbol. X is partly constant and partly varies as y. Now we want to make this one an equation, so we are introducing two constants, h and k. H we usually multiply by 1, then k multiplied by y as usual. So it becomes x equals to 1 times h, you get h, plus y times k, you get y, k. That's our formula. X is partly constant and partly varies as y. Now, unlike what we were doing in the direct variation, joint and inverse variation, whereby we were given just one set of complete variables to substitute and find the value of k. In the partial variation, you'll be given two completed sets. The question is saying x is 4 when y is 8, and also x is 3 when y is 5. You'll be given two completed sets to form simultaneous equations with respect to the formula. The formula is saying x is equals to h plus yk. So in place of x, we are writing down 4, h will remain unknown. In place of y, we have 8, and k remains unknown. That's equation 1. Equation 2, x is 3, h remains unknown, plus y is 5. So we get 5k, equation number 2. So take note of this. Simultaneous, partial variation results in simultaneous equations. We are substituting these two sets of variables into the formula. Now we have equation 1 and 2, and you need to solve this equation simultaneously. So I will create space here, and let me take the last question here. Number C was saying find x when y is 10. Find x when y is 10. We'll come back to this one later. Let me erase this part to create space. Alright, so the task at the end is we need to solve these simultaneous equations, and they read 4 equals to h plus 8k, that's equation 1. Then 3 equals to h plus 5k, that's equation 2. We can use elimination method, where since we already have h here with equal coefficients, so we start simply by subtraction. 4 minus 3, we get 1. H minus h, 0. 8k minus 5k, we get 3k. And we need to find the value of k, so we divide both sides by 3, like this. Then we get the value of k. So it shows that before you go through this tutorial on the topic variation, you must go through the tutorial on how to solve simultaneous equations. Mathematics follow a certain order. Now, since we know the value of k, let's substitute k into one of the equations again, find the value of h. Suppose we take equation number 1, 4 equals to h plus 8k. Now, 4 equals to h. In terms of k, we are writing down 1/3. Then we have an equation 4 equals to h plus, since they cannot reduce, numerators will multiply 8 times 1, 8, denominator 3. Let's introduce over 1, another over 1. Now we are going to multiply by 3 every term, times 3, times 3, and times 3. Then we reduce this one. Now we have 12 equals to 3h plus 8. Let me create more space here. Alright, 12 is 3h plus 8. By grouping, 12 minus 8 is 3h. 12 minus 8, that's 4, is 3h. Then we divide both sides by 3, by 3. 3 into 4, we get 1, remainder 1 over 3. That's the value of h. Now k is known, h is known, and we can use these terms in the last part of the question to find the value of x. The last question was find the x when y is 10. You go back to the formula. The formula was reading x equals to h plus ky. That is, x is unknown when h is 1 and a third, and k is 1/3. Then y is 10. Then you solve to find the value of x. So let's quickly solve that one. Also, I expect that you know how to handle fractions. X equals to, we make this one improper. 3 times 1, 3 plus 1, 4 over 3. 1 times 10, get 10 over 3. Then x is equals to, since we have equal denominators here, you can simply have 3. Then we get 4 plus 10, we get 14. So x is equals to 3 into 14. That's 4 times in 12. Remainder 2 over 3. That's the value of x. You must be comfortable with handling mathematical problems involving negative, positive numbers, common fractions, and decimal numbers. Check with the previous tutorials where we addressed those issues. I feel we can just get one more last example on how to handle partial fraction. Let me create more space. And let's say the question is given that the expenditure $E of a family is partly constant and partly varies. It's the number of people in a family, number of people P in a family. The question is saying there is a partial variation or partial relationship between the cost of running a family and the number of people. If the number of people in a family increases, the expenditure to meet daily demands of the family might remain constant, or it can respond but partly or partially, thus being slightly. Now the question is, number A, write down the equation connecting E for expenditure, P for people, and two constants, H and K. Right. So you say, given that the expenditure E is partly constant is replaced by 1, and partly, that's addition, varies as the number of people, P. Now we are going to introduce H. H will multiply by 1, K will multiply by P. Thus, E equals to 1 times H, H plus PK. That's the formula. Let me write the formula. E equals to H plus PK. After having the formula, we need to find the value of the constants H and K. And in order for us to do that, we must be presented with two sets of complete variables: expenditure, number of people, another set, expenditure given, and the number of people. So we formulate simultaneous equations like this. Number B. The expenditure is $40 when the number of people is 5, and also the expenditure is $30 when the number of people is 3. Find H and K. Now we want to find the value of H and the value of K. Still we go back to this formula. Here it is. Expenditure equals to H plus PK. Then we say we are given two sets. Expenditure is 40 when the number of people is 5. So that's 5K, equation 1. We have another set again. Expenditure is 30 when H remains unknown and the number of people is 3. Like this. Now we successfully formulated simultaneous equations, and we are going to solve these simultaneous equations. Let me create this space. Right. 40 is equals to H plus 5K. 30 is equals to H plus 3K. Then we subtract 40 minus 30, we get 10. H minus H, 0. 5K minus 3K, we get 2K. To find the value of K, we divide both sides by 2 by 2. Now 2 into 10, 5. 5 is the value of K. And we need the value of H. You take any one of the equations. For instance, equation 1, 40 is equals to H plus 5K. In place of K, now we substitute by 5. That is 40 is equals to H plus 5. Now the value of K is known, is 5. So 40 is H plus 25. By grouping method, 40 minus 25 is the value of H. And we get 40 minus 25. 40 minus 25, 10 minus 5, 5. Then 4 minus 3, we get 1. 15 is the value of H. Now we know the value of K and the value of H, which means we are ready to find the missing variable. Let's create a question asking for the missing variable. And the last part of the question will calculate the expenditure for a family with 7 members. We want to calculate the missing variable, and the missing variable is the expenditure. So we bring back the formula. The formula was expenditure equals to H plus PK. So now expenditure is unknown, but H is now known. H is 15 plus the number of people is 7, then K is 5. So the expenditure is 15 plus 7 times 5, we get 35. So expenditure is 15 plus 35, 5 plus 5, okay, 35 plus. We do not afford to make any errors in mathematics, so do not use shortcuts. Show working until you get very accurate answers. So we have 15 plus 35, I will do better. Write down here 5 plus 5, that's 10. 0, 1, 3, 4, 5. The expenditure is $50. That's partial variation. So what I would advise you now is when you go through the topics, when you go through this tutorial, find someone to teach. It does not benefit that him or it benefits you. When you teach someone, it's so difficult for you to forget what you have taught someone. That's variation for you signing out.